Okay, so we will deliver pretty much the same tour. My specialty is more building automation systems, and Dan's specialty is more green building. So if you have questions that are really technical in those areas, you might want to join one or the other, okay?
We are large enough that we should split it into two. So yeah. I'll cut you down the middle if you guys want to stick with our ends or with other hands.
Green building, so LEED, everything that's about net zero. So I hope people are left on my side too. If you have too many, I'll take some back. Perfect. Okay, great. So we're here in the Hunter Student Commons, and that's what we refer to as the block. And these are the features that John was talking about. So it's used for natural ventilation as well as architectural features. So if you want to look up, it's actually pretty neat to look at. In the pictures he showed, students were sitting in this area. It would be very comfortable, actually. Good airflow.
Why they did little channels all around?
I don't know. It's a very good question. Yeah.
Great thing to. This is the government stuff.
Yeah, I don't know. It looks like an architectural feature, but maybe it has a functional piece. Yeah, it would be better too. Yeah.
So is there like airflow?
Absolutely.
Forced airflow?
It's not forced, it's all passive. So you have the pressure in the building and it just pushes the hot air out and then you get circulation throughout the building. Chimney effect, yeah. 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 How are you?
Good, how are you?
Good. Good to see you.
Yeah.
All right. All right, so we're going to move to the basement now. Okay. Yeah, so you're right. This is the underfloor air distribution system that's throughout both the Hunter Student Commons and the tower. Radiant floor here. We needed a way to heat this entryway as well. So as you walk here, you can look also at the features, the architectural feature as well as the lighting in the building. Entryway of the tower. So when it was under construction, the tower went up first. So they actually blocked the Hunter Student Commons and the link completely. And we had entryway doors coming from both ends of the building. And after the link was opened, then they could close these two doors, which became part of the offices. So the Office of Sustainability, and then I forget, student enrollment. On the other floors, we also have Faculty of Social Studies as well as offices for IT and administrative offices. Okay, so part of the efficiency of the building, we had to put very efficient elevators. Elevators can be quite demanding on energy, so we have the standard new way of elevators. We're going to go to the basement first, and then we're going to move to the 7th floor. So Dan is doing the opposite, 7th floor, and then going to the basement. So we're going to look at with the D. So first group can go to D and go downstairs, come out the elevator and just wait there, and then we'll join you.
Basement.
Okay, great, you made it. Okay, so we're gonna go look at the gray water or the rainwater system. So you can come out this way. So I talked about IT a little bit, the ONTs that we have in the buildings. So throughout the building, we have a different technology. So it's not copper, it's optic fiber. So all through the building we have those ONT cabinets which require a special type of IT personnel to take care of it. So that's what these are. They were challenging. We're not used to how much they can take on one device. So we had to adjust to that new technology when we when we took the operation of the building. Okay, so we'll keep going. Okay, so electrical room, so and I'm saying this because I know there's some people interested in electrical here. So the PV system, our metering is in this room here. I'm not gonna go in just because it's electrical. But then the rainwater system is here. There we go. All right. It's a little bit loud in there, so what you'll see is the cistern. So the concrete wall at the end is where the cistern is that you saw in the slide, if you remember it. There was water in it. And then there are tanks. So one has the rainwater collection and then the water that's distributed to the building. You'll also see a number of, they look like barrels. They're the filters for the rainwater. So when it comes from the roof, it's filtered. And our maintenance staff takes care of cleaning those filters regularly so they don't plug. The other thing that we found with this system, we had to clean the upstairs, like on the roof where the water comes into the pipe. That tends to get clogged, so we had to put mechanism in place, make sure it doesn't get clogged. Okay, so I'll have, yeah? That's fine, yeah, that's good. It's not really a mechanical room, so just limited space. So if you want to just kind of come in, look, and then you can come out rather than all pile in here. Does that sound good? All right. I can't speak specifically to this year, but typically no. That's what John also was saying, that we don't, even this, I would have to crunch the numbers, but in general, no. Yeah. Yeah. All right, so you notice the purple pipes, so that's to indicate the rainwater. And also another good question about, did we get enough water this year? I'm not exactly sure. I assume not, because we typically get big rain events and then we were dry for a while. So right now we're probably having to make up a little bit with domestic water to keep everything running. So you just
pump water into that same container? Into
that same container,
okay.
That's correct. Yeah. So we have, everything is metered, so we know exactly how much we have to make up in that condition. Yeah.
So was this a lead requirement, or like what was the reasoning for sizing it the way it was sized?
There is a lead component to it. There is also the idea that because we are in a dry climate, that all the water that we can reuse, we try to reuse. So I think it's recent that people are paying more attention to, okay, we put all these cisterns in place now, how much are we actually collecting? Is it worth it? And this is when we're finding exactly what we know now is, well, I'm not sure we're going to do it next time. We have to analyze it. Yeah.
I have a question. I'm kind of seeking validation to my thoughts and opinion.
Yeah.
It was already asked, but like from an architectural point of view, you are looking at an ROI of 23 years, right? So any major project will be after that, I believe. Talking about continuous improvement on your infrastructure, on your BAS, are you dependent on data and analytics, and does that heavily influence your decisions for investments, for new projects? Is that so?
Yeah, that's a big question. Well, many aspects to it. So you're thinking about the technology renewal, or you think about the infrastructure renewal?
Infrastructure related to building automations.
Related to building automation. So what I say usually is that what can, influence how often we need to update our systems. It unfortunately is the reality, right? So when you run an automation system, if you look at the upgrades down the road, sometimes you just don't have a chance, just like your personal computer, right? They say, well, you have to upgrade because it's no longer will be supported. So to think that our building automation will last 23 years is not realistic. Our controllers might or might not, I don't know, because we have relatively new technology for our controllers for our building automation system. And then our vendors are typically trying to keep up with the operating system, right? So, and these upgrades will happen in cycles of about 10 years in my experience. So the next big renewal, we are just finishing an upgrade, and the building automation system is not specific to this building. If you look at the software piece, it's campus-wide. And so there's kind of two levels of planning when it comes to technologies in the building, right? So you have the hardware and you have the software. So yeah, so I'm not answering specifically your question. Our plan is about every 10 years we do a major upgrade on our building automation system to keep up. And then for the controllers, we have to analyze how long these new controllers we put in MacKimmie Tower will last.
Okay.
Yeah. Yeah, anything else?
Yeah. Question. Then you mentioned energy efficient elevator. So what is it? Is it like premium models or what makes it efficient?
So I can't speak to the technical details of it, but what's efficient about it is the way it delivers passengers to the different floors. So rather than having a traditional elevator where everybody presses a button, hoping to go up, it distributes people depending on which floor they want to go to. So it's more about the algorithm it uses to deliver passengers. Yeah. Okay, let's go see. We talked about the heating and cooling. We are in a district energy system, so we have a cogen system that generates about 12 megawatt of power at our heating plant. We have about 8 kilometers of tunnels where we distribute heating water and cooling water, chilled water. We also distribute natural gas, and it all comes to our tunnels, so about 8 kilometers of tunnels distributing all this. And then we have a heat exchanger. So it comes on the tunnel side at 200 degrees Celsius, and then we bring it down to about 70 degrees. In the case of the tower, in the summer day, we are just at the level that we need to do domestic hot water heating, because we also use that heating water to heat domestic hot water. So what you'll see here is the entry point from the tunnel to our mechanical room, where the heating and cooling is coming in. You'll see the pumps, and then you'll have the distribution system that goes from here to the tower, as well as to the Hunter Student Commons. So there is no vault where we get our heating and cooling in Hunter Student Commons. It all goes through the tower. You'll also see a lot of metering. So metering is what my group takes care of, so I'm quite passionate about it. So we have water meters, so we can track all the information with the rainwater system. We have our thermal meters. So electrical meters are not in there, they are in the electrical room. But I will point out the thermal meters, just for your information. Okay, so that one I think we can all fit in there. Just don't touch anything that's hot or spins. Thank you. Okay. So we're probably gonna just cut for the entry to the tunnel. Thank you. Oh. Waited too long. There we go.
Secret?
Yes, sir.
Okay, come on in. Hold the door. Oh, thank you. While I find the key again. Oh, AL. It's a bit loud in there. If you need hearing protection, it's in there, but I won't be screaming on top of all this. So what you'll see is a number of pumps on this side, and then you'll see the domestic hot water tanks on that side. When we go further towards that end, there's a door that goes to the tunnels. That's where the heating water chilled water as well as domestic water come in. Okay, so look around, and if you need hearing protection, it's in there. And we'll be rather quick in there, okay? Great. It's not too bad. I thought it would be louder. No, we're not going to go through. This is the tunnel, so yeah. Usually that door is closed and we need permission to go in the tunnel, so we won't be able to go in there. But this gives you a sense of the size of the domestic hot water tank for both the tower and the block, our Hunter Student Commons. So it's not very big. Thermal meters. So these are meters that have 2 temperature sensors and a flow sensor, and it's just pure thermodynamics where you calculate the amount of energy that's sent to a certain system, right? And all this is connected to our BMS system. Okay, so we have for the main heating, we have for the domestic hot water heating, and then we have the more traditional behind you. That's our main water meter, so it's a dual head Neptune turbine meter, which is also connected to our BMS system. So we use that to monitor the total usage in our building.
It's all connected to all the areas?
Yes, absolutely. So those conduits, so with the orange box indicates that's a BMS control. So that means it's going back to our BMS system. So it's fairly small. You notice we don't have boilers, we don't have chillers, so it's the lack of equipment that you're visiting right now, right? So we'll go for the views next. It's more impressive. But this is really small compared to a typical building. Okay. Oh, thank you.
So you see that 8 kilometers of pipe coming out of your district heating system. Is that all in tunnel or is some that are very?
No, completely in tunnel. So
every
yeah,
process.
it's actually 8 kilometers of tunnel, and then the pipe. There's even more because you have a supply and return pipes. And, yeah,
Everything is successful.
Yes, through the tunnels, and it's big enough to ride a bike.
Yes.
That's about the size of it, but that's it. So yeah, okay, we're gonna go to the 7th floor. Any other questions? We're good? Okay. Oh, I'll let you. Yeah, perfect. Okay, C. So first group. You can split in 2 groups. It's located. Which building do you know? Yamnuska? Yeah, around that area. Yeah. So it's nice to finish with a nice view. Okay. So this is an example of a space for MacKimmie. So as mentioned, this is the 7th floor, so you'll have taller ceilings. What you can see here is the radiant panels. So we typically heat by the windows, and on a typical floor, which is a little bit lower, we'll heat and cool in the central zones of the building. And John talked a little bit about, in what condition do we heat, what condition do we cool, and then the shoulder season, that's the complex one, right? So that's the time when we can open the windows as occupants. You can open them when you're in cooling season. However, you'll learn quickly that it's really, really hot in between the windows, so you most likely will close it quickly. So rather than limiting the occupant, and that was actually a design discussion that went on, it was to let the occupant learn from their mistake and say, okay, I'm opening the window when it's really, really hot. I got hot, I'm not going to do that again. So we'll see how well that works. Generally it works. If somebody opens a window like that when it's hot outside, we will feel it on the whole floor. It's quite quick to impact everyone. So since you're there, standing there, how about you press the button for us? So we'll open the window. So if you come over, yeah, and you can press this one down here. Okay, once, perfect. So now we just let it do its thing. So if we're allowed to open the window will open. Did you press hard enough?
Yeah, it's blinking. It was.
It was blinking. So if it doesn't let us, that means that we can't open it. Sometimes you have to be patient with it. The blinds can also be controlled here. So we notice that the windows in that room are open and not this one. On the top. Not sure why it doesn't open. It should open in this condition because we have about 20 degrees outside. We probably have a warmer, it might be too warm in there. So I would open a window, feel the warmth and go, yeah, I think it's better close it. It opens automatically from the top and it opens from the occupants down here as well. So when you're feeling too hot, you can adjust it. I'll have to check with Dan if he managed to open it. We can, I'm kind of disappointed. It could be that it just refuses. The blinds, I can try the blinds. Yeah, it's not happy. That's my team, we're gonna have to deal with this. So the blinds would also be possible to control. So if you, afterwards you can come on this side and you'll notice that where the sun is shining on the facade, the blinds automatically came down and tilted. And so it should be, cutting the solar gain quite a bit.
It all relies on mechanical, I guess, movement, kind of things change or?
Temperature, yes. Yeah, it's a combination. Like I said, there are many sensors. So if it's raining, the windows will close. If it's too windy, the windows will close. That's for the outside windows. Yeah, inside it's working with the HVAC system. So if it's too hot, it'll try first the windows to try to make it better.
Do people complain about, because it's not, the air is not filtered, right? It's outdoor air.
That's
Is
right.
there does it make the space dusty?
It could, yeah. It could make it smoky, it could make it dusty. You're right, there's no filtering of the air coming in. So that's why when there's a wildfire smoke in effect, then we typically will rely on mechanical systems more so we can filter the dedicated outdoor air filters. Dedicated outdoor air system will provide filtered air.
And that comes in
the underfloor, so it's a slow moving air.
both for cooling
Not so much for cooling, more for ventilation, and we do the cooling with the radiant panels. Yeah. It doesn't push. It's not like a 13-degree overhead, air, forced air that you felt on your shoulders when you're sitting in an office, right? You won't really feel it, but it'll provide just enough to maintain the space conditions and the CO2 levels.
Are you using the hot air generated over there anywhere, or is just the upper part of the world? Because if it's a hot air, it might be escaping from above there. So are you using this hot air somewhere or circulating it inside the building for heating or ventilation, or is just the purpose of it is using standing over there heating it?
Yeah, it's a lot for the purpose of feeling it. Typically, if the mechanical systems will kick in, the windows will typically be closed because it's too hot. So, and then if you want to feel it, it's more about feeling the airflow than cooling in some cases if the occupant decides to open their window. Yeah. The algorithm to control the windows relative to the HVAC system is extremely complex. It took us a handout to try to explain to the occupants how the thermostats work. And even then, right? So it shouldn't be that complicated for the little mechanical systems that we have, but that's a reality. because the comfort zone is a little bit different, people are quick to try to say, okay, how does this actually work? Because I'm really hot right now. Is this normal, right? So we're standing, we're talking, but if you were sitting at the desk, you might actually be comfortable if you just open the window and feel the breeze, and even though it's 25 degrees. Yeah, so it is such a shift in the way of thinking. So I appreciate the question that came about, the comfort. It's not a parameter that engineers typically think about when they think about, okay, what can I control in the building to make it more efficient? To tell people to say you're going to be, in a different comfort state.
It's a personal.
Yeah. Exactly. Yeah. Yeah.
I just see there's no screens. How are you keeping birds?
Yeah. There are screens on the windows. Yeah, and it's a really good question because even during construction, they were putting the windows up and some birds were coming in already, right? And so they had to put screens pretty much right away. Yeah. Yeah. Demonstrating. Okay, so welcome to, look, you know what, we're just gonna go in that other room and try the window. I see the control is blinking in an unusual way. And the windows in the room are controlled by zones. So you'll have a few windows open at once in a given room. So, yeah. I can control the blinds, and it looks like it's not letting me control the windows. It could be because it's too hot or the conditions are not for that. But at least we can control the solar gain with the blinds. So, yeah. All right, we saw at least the blinds go down. All right, we'll deal with the rest later. Any other questions about this?
I noticed that the stove are not covered.
Yes.
So people are allowed to
yes.
change settings.
Yeah, they are, and like I mentioned, it's super complex because we have I think it's a 4-degree deadband. So for those who are familiar with thermostat, that means the user will start pressing on the button and nothing will happen until something happens. Yeah, so it is a little bit. They have control, and it does work, but it is quite a large deadband. All right. Okay, let's go to the mechanical room. So what you'll see there again, as John mentioned. Okay, so the mechanical room, as John mentioned, this used to be the mechanical room, the whole floor for the same building. And what we're going to visit is the mechanical room for the whole building as well. And it's a lot smaller than it used to be. That's what's impressive about it. So we're going to walk around this way and just go look at the air handler. You'll see a couple electrical meters. You'll see there's a heat recovery system, evaporative cooling system as well in the air handler. So you can peek through the windows. And you'll see also the 6-way valves that are used for the radiant panels. And those valves are what allows the panels to shift from a cooling mode to a heating mode in different seasons. So let's keep going this way. So the reason this room is interesting is because you see the roof and you see the features that where the natural ventilation was in the Hunter Student Commons. So we were standing on one of those chimneys there. So that's what it looks like on top, so it provides some daylight and ventilation. The metal structure is what John was talking about for PV ready. So if we do get the opportunity, we can add photovoltaics on top of the Hunter Student Commons. I don't. Unless you have a checkbook, again, like we do. Yeah. I don't know the number, and it changes so quickly, right? Yeah. So, and then what's the other feature that we haven't talked so much about is the building integrated photovoltaic on the windows there. So that's also an interesting way of generating power. And while we're here, I'll just point out the solar panels on the social science building that you see on the left there. And nothing to do with MacKimmie specifically, but it's interesting because it is a completely vertical array. and it produces, you know, when at times when you optimize your PV systems on the rooftop, your angles are optimized for, you know, the peak time when you're going to produce. When they're vertical like this, it's a different pattern of production, right? So when you add the two across campus, it becomes really interesting pattern for production. So this is something we're keeping a close eye on, but so far it's been really, really, it's very good in winter because the sun is much lower, right? That's right, we don't need to clear them, they stay clean. So yeah, we're gonna keep monitoring the performance of those panels, but they're really interesting.
I know it's interesting to publish, I don't know, you know, on TV.
Yeah, we do have our, there is a dashboard for the PVs, I believe. I think so.
Yeah, that makes sense.
Yeah, yeah, so students can use that data and look at it as well. Okay, the promised mechanical room. Let's go see it. Okay, so this air handler serves the entire building, which is quite remarkable because it is a big building. And it's a typical air handler other than, you know, it has tubes for heat recovery. The things that we can point out are the energy valves. So we have a number of Belimo valves up there that we all use for energy monitoring, so to know which system is using energy. So I'm not sure how much you'll see. Does anybody see a light switch on the air handler? Donald, I think behind, are you on the light switch on your back? Is there? No. Okay, can you flip the switch, please?
Sure. You go.
Hold on. All right.
Nobody wants to touch it.
I'm coming. That's a bad idea.
Could possibly have.
We'll have to. No, that's not it. Good call. No. This is the. I wanted to get the evaporative cooling system is in there, so it may or may not. It used to be a switch, but it might have put it on a, timer. I don't want to flip it. If you don't want to flip it, I don't.
I thought might launch something.
It might. So the reason is that it would turn on the light inside the air handler. It's probably this on a timer right now, but I don't want to risk it either. So
that's the air that comes.
That's right. Yeah. So
Like in the rooms.
that goes under floor. That's where the air comes from. So dedicated outdoor air system, and it's going all the way. It's filtered.
So this is for the whole building.
For the whole building. That's right. Yeah. So you have, yeah. It's pretty small. Our energy meters again on the wall. And then if we...
What's the square footage of the building?
I was looking at that. I can't remember numbers very well, so I'll have to... about 30,000
Square meters.
square meters.
Okay.
Yeah. But I can't remember if it's just the tower and the complex.
Okay.
Yeah. And then for electrical people, a little bit of finally, there's one of them.
Only one?
Only one here. There are more on this floor. They're in a different room. Okay, and the other thing I wanted to point out are the 6-way valves, which is a little bit unusual for a building. So these valves will switch between heating and cooling. So that's what they look like. Yeah. Okay, any questions?
This is the light switch.
Yeah. Just ask Donald. He'll. All right. Any? Okay, let's go out and let's go back.
So I'm curious, the long-term plan is to move from high temperature to low temperature?
Yes.
With this building, I don't know if there's a way to do that, but to kind of prepare it so that the conversion will be
Yeah.
easier maybe?
This building is ready for, moving to a
Does
low
it mean
temp.
you need like 2 different pipes, or you just build the pipes bigger and they'll carry?
The temperature right now is about at 65-ish.
So it's already.
So it's already built
okay
to be working
through
at
that,
low temp.
whatever the converter is at that.
Yeah, so every building we're going to build moving forward is going to be in alignment with our district energy decarbonization study, and it's going to be able to work at low temperatures.
And when you do renovations of other buildings and have the opportunity, you'll swap that out however you can.
Yeah, and that's exactly what a deep retrofit could do,
Yeah.
right? Versus just putting energy improvement measures in the building, right? That where you adjust set points, or you like the small things. The deep retrofit really goes to that level of system,
Okay.
and so that's what we're looking at doing a lot more on campus,
Exactly.
because we've done years of energy improvements in other buildings,
Yeah.
right? So that's our next logical step. Yeah. Okay. We're just using this because it's more straightforward. Yeah, it's fine. I think. There we go.
It's funny when I'd never seen these kinds of, and it was quite confusing the first time.
The first time, yeah. You want to press that button? We're going to go through M. Oh, yeah, the font gets small sometimes.
Fun is pretty small from the side.
Okay, what's this one? I'm giving you all the tricky jobs. Okay.
Are all these meeting rooms used? Or?
Yeah, it's a really good question. I was wondering if somebody would ask.
Meeting rooms, there's so many of them.
So they are available for everyone, and we have to book them through a special system. So yes, they are used. Monday and Friday, a lot of people work from home, and that's why it's not very busy today. Normally at 4 p.m. you'll have like a lot of traffic in the elevators, and so we're kind of fortunate to have this store off hours a little bit.
I'm kind of curious in the operating costs from as much as you save for all of one thing. Do you have any idea, i.e., because you're going to pick up more in window cleaning, you're going to pick up more in like cleaning per se itself. Has anybody ever compared what it was like back in the day to now to see like what offsets something else? That's kind of, I'm curious.
Yeah, we haven't done the analysis yet.
Yeah.
Because it's fairly new, but it is a question we're looking at, investigating for sure.
It'd be really interesting to
Yeah.
see the categories that have changed, right? Not necessarily the money, but as much as the categories.
The areas where we need more, yeah.
Exactly, more attention to.
I can tell you we need more for the windows, for sure.
I bet.
Is there a window cleaning system?
No, there isn't. No, there are anchors to clean the windows, but we have to get people to clean them. Yeah. Okay, perfect. Okay.
Take some computer power with that.
So that's the only one control panel, there's none inside.
Exactly, yeah. What if you just go on? You can't.
The elevators.
Big discussion.
Yeah. All right, so that concludes the tour here. I don't know if you left anything up there. We'll go back. And for those who want to head back or network, whatever you want to do from this point on, it's up to you. If you have any other questions, I'm here. Dan is still there. I see him, so we can answer those. Yeah. Okay, thank you. Thank you. All right.